Hello, dear students. Let us to discuss uniform circular motion. See, when an object follows a circular path at a constant speed, the motion of the object is called uniform circular motion. The word uniform refers to the speed, which is uniform means constant throughout the motion. Suppose a particle is revolving with a constant speed, say for example 5 meter per second. So at every point the speed is 5 meter per second only. Then we can say it is uniform speed, okay, or uniform circular motion. But remember, in case of uniform circular motion, at every point the speed of the particle is same but not velocity, because here the magnitude of the velocity at every point is same. That one is also, for example, 5 meter per second. But what happens, the direction of the particle is continuously changing from point to point. So hence the velocities are different at different positions because of the direction, remember. So as the magnitude or direction or both will be changes, then definitely we can say it is accelerating. Okay, so then definitely we'll get the acceleration. Acceleration is not zero in case of uniform circular motion, remember, because by taking 2 points, only if you consider the magnitudes, so we are getting the same magnitude at two different points in circular motion. Okay, because the magnitude remains same. Okay, so the change in velocity or change in speed is zero, but change in velocity is not zero because of the direction. Is it clear? Okay, see, let us to discuss the expression for the acceleration in case of circular motion, and the expression itself called as centripetal acceleration. See, in this figure, okay, see, check this figure. In this figure, a particle is revolving around O. O is the center and path of the particle is circular in motion. Okay, so let us to take 2 points P and P dash. See, this one is the P, another point is the P dash, are the 2 points. Let R be the radius of the circular path. R be the radius of the circular path. See, at P the velocity is v, and at P dash the velocity is v dash. Remember, the position of P can be denoted or represented with the vector OP, and OP dash is a vector which gives the position of P dash. So let R and R dash are the two vectors which gives the direction or the position of the 2 points. So now at P the velocity is v, and at P dash the velocity is v dash. But remember, it is uniform circular motion means the magnitude of v and the magnitude of v dash are same. Let we can say that magnitude is v. But v is not equal to v dash because of direction. Only the values are same but not the directions. So two velocities are said to be same only when having both magnitude and same direction. So that generally we can say it is equal vectors. Okay, but here v and v dash are not equal vectors because of the direction. Okay, so now then how to calculate the change in velocity, that is v minus v dash. So let us to discuss this with the triangle law of addition of two vectors. Just you have to show these two vectors v and v dash as the two sides of a triangle. Okay, so v and v dash are the two vectors, so that can be represented in figure. So AB indicates vector v, and AC represents vector v dash. But remember, AB equal to AC because of magnitudes are same. So now one more vector BC, so that gives the change in velocity delta V. Okay, now come to the triangle law of addition of two vectors. According to the triangle law of addition of two vectors, here vector AB plus vector BC equal to vector AC. Clear? Okay, so this is about the explanation. Note on this explanation, simple explanation is there. Clear? Okay, so now see the same explanation here. Delta V means change in velocity. If you want, just V minus V dash, magnitude of V minus V dash gives the change in velocity. Okay, but the magnitude of V and magnitude of V dash are same, remember. So the change in velocity is magnitude of V minus V dash. See, the change in velocity V minus V dash as the particle travels from P to P dash in a time interval delta t can be obtained by the vector method shown in the figure. Okay, so now see here, from the triangle law of addition of two vectors, vector AB, see, vector AB plus vector BC equal to vector AC, or vector BC equal to vector AC minus vector AB, or vector AC minus vector AB equal to vector BC. See, vector AC minus vector AB equal to vector BC. See, now vector AC is V dash and vector AB is V, so, and their difference is delta V, that is vector BC as delta V. Similarly, you can apply the triangle law for this triangle OPP dash. Okay, so in this also there are two vectors, okay, OP and OP dash are the radius vectors, and PP dash is change in the position of radius R. Okay, so that is similarly here also we can write that vector OP plus OP dash equal to, see, vector OP plus PP dash equal to vector OP dash. So from this, vector OP dash minus vector OP equal to PP dash. So that one is change in the position of the radius, that we can call it as delta R. So we can write R dash minus R equal to delta R. Okay, cleared? Okay, so next one is these two triangles, okay, are similar triangles because the angle A or CAB is same as P dash OP. Okay, so now if two triangles are similar, then their sides are proportional to each other, or the ratio of their sides is constant. So that is, here we can write BC divided by PP dash, and here AB is V, okay, and OP is R. So from that we can write it as, see, BC divided by OP dash, see, BC divided by OP dash equal to AB divided by OP. So that is, BC is change in velocity and PP dash is change in R, that is radius. So AB is V, OP is R. Delta V by delta R equal to V upon R. So delta V equal to V upon R into delta R. Okay, so now we are getting the final expressions here. See, we find that the acceleration of an object in uniform circular motion is always directed towards the center of the circle. Let us now find the magnitude of the acceleration. So the magnitude of the acceleration is limit delta t tends to 0 delta v by delta t. So that one is delta v equal to v upon r, delta v equal to delta v upon r, delta v upon r into delta r. Okay, so divided by delta t as usual. So delta r by delta t, delta r is the change in the position of radius, delta r is the time taken to change that radius. So simply delta r by delta t gives velocity. Okay, so therefore delta r by delta t equal to v, you have to substitute in the above equation. So we can write limit delta t tends to 0 v upon r, then one more is v divided by delta t. So therefore delta see, check the expression. See, if delta t is small, delta t is also small. Okay, so delta r equal to v into delta t. So therefore delta r by delta t as v, that is change in position by time, is velocity. So therefore limit delta t tends to 0 delta r by delta t, we can take it as v. So therefore the centrifugal acceleration A equal to delta v by delta r as v upon r into v. So that one is the acceleration. So this acceleration is called as centripetal acceleration, and finally we got a is proportional to v square divided by r. So this is the final expression for centripetal acceleration. Okay, so note down the expression for centripetal acceleration. Okay, so centripetal acceleration is v square by r, where v is the uniform circular speed and rv its radius. Is it clear? Okay, thank you.